today for you guys, but what we're going to do is we're just going to do the math moment together. Then we're going to do some work on your calculator and fill in the note guide. So the things that you might want out are your math moment paper to complete this one math moment, the note guide because we are going to go through the examples, and if you want to try and follow along with the video, your calculator to be able to do so, and you are going to do an example with that also. So first we're going to start with the math moment. Notice that it says this function, and then it gives us an equation. And it says that that function models the height of the soccer ball, h, as it travels a distance x. What is the maximum height of the ball? So you can see that he's going to kick the ball. It's going to travel along the curve. And at some point along the curve, it's reaching its maximum height. Since the curve is parabolic, okay, it's like a quadratic in its shape. And that means it's symmetrical. So if we see a point at 0, 0, and the next time the ball hits the ground or the 0 level is at 90 feet, we expect the middle of the arch to occur between 0 and 90, which would be at 45. And since, again, it's parabolic in nature, that is our maximum point. And so we expect to get that calculation. So we don't know what the maximum value is right now. We don't have the entire coordinates of the maximum point. But we do know that the x-coordinate, or when the maximum height occurs, is at 45 feet away from the kicker. So then in order to calculate the actual maximum height, we're going to use the value of the equation that they gave us and the fact that we know that this maximum height will occur at 45 feet away from the kicker. So we're going to plug 45 in for x, and then we're going to use that to help us calculate h. So in our calculator, we can do this calculation, and it gives us that the height is 20.25. And if I look on the axis, I can see that that is height measured in feet. So that is the maximum height that the ball is going to reach. Okay, so we're going to be exploring more about quadratics today and focusing on intercepts and maximums and how to find those on the calculator and also by hand. Okay. So if you have your note guide, you'll notice, and if you don't, you should still write down the equations and stuff that we're going to use. That we're going to use our calculator in the first example. We're going to graph this equation on our calculator, and we're going to try and figure out the vertex and the x-intercepts of the graph, and from that be able to answer questions about the axis of symmetry, the maximum or minimum value, the domain, and the range of the graph. Now, we're going to do this on your calculator, so I'm going to show you a YouTube video where somebody explains how to do it on the calculator, so you guys can follow along with that video if you like. Notice here that besides finding the values that we're going to look for in this row of the chart, the second row is a place for you to make calculator notes or notes about the keystrokes. So pay attention to what the keystrokes are, and then we will go through and repeat those to answer our questions. We just want to make sure that we can use the calculator correctly. So going to the video.
Vertex, Y-Intercept or vertical intercept, and X Intercept or horizontal intercepts of a quadratic function. In the previous video, we did this by hand. So the first step is to enter the function into the calculator. So we'll press y equals, clear any old functions by pressing clear, enter the new quadratic function. So we have 2x squared minus 14x plus 7. Let's start with the standard window. To make sure we have the standard window, we can press zoom 6 for the standard window. But notice how we need to adjust the window now so that we can see the vertex. So we'll have to decrease the y minimum. We can also get rid of this piece of the graph by increasing the x minimum. So we'll press the window key. Let's increase the x minimum to, let's say, -2. We'll press enter until we reach the y minimum. Let's decrease this to -20. If this doesn't work, we can always come back and change these values again. So we'll go ahead and press graph. Notice how this is a pretty good window. Here's the vertex. Here are the two horizontal intercepts, or X intercepts. And here's the vertical intercept, or Y-intercept. Notice how because the parabola opens up, we would find a minimum function value at the vertex. If the parabola opened down, we would have a maximum function value at the vertex. But because our parabola opens up, in order to find the vertex, we'll press second trace and select option 3 for minimum. Again, if the parabola opened down, we would select 4 for maximum. So press 3. It's asking us for the left and right bound. So for the left bound, we want to be to the left of the vertex, so we'll arrow over to the left. Anywhere over here is fine. We'll press enter. Arrow over to the right when it says right bound. Maybe somewhere here. Press enter. When it says guess, we can just press enter again or move the cursor closer to the vertex. Press enter. We need to recognize here the calculator is not perfect. The coordinates would be 3.5, comma, negative 17.5. We can also express these as fractions. Let me show how you can convert these decimals to fractions on the calculator. So if we go to the home screen by pressing second mode, we can type in 3.5, press math. Notice how the fraction option is already selected, so we'll press enter twice. Enter, enter. It converts 3.5 to the improper fraction of 7 halves. And then for negative 17.5, we can do the same. Negative 17.5, math, enter, enter, and it gives us the improper fraction. So these coordinates are equivalent to 7 halves, comma, negative 35 halves. Either of these two forms are acceptable. Now we want to find the Y-intercept or vertical intercept. So if I go back to the graph, we can see that the Y-intercept is here. We just can't tell the coordinates. But remember, any point on the y-axis would have an x-coordinate of 0. So we can find this point by pressing second trace and then select option 1 for value. Enter in the x value of 0, and then press enter. So when x is 0, y is 7, which would be the y-intercept. The y-intercept is the point 0, 7. Of course, we could also just find f of 0. If we sub 0 for x, notice how the function value would be 7. And now we'll find the x-intercepts or horizontal intercepts. Notice how we have one here on the left and one here on the right. You can only find one at a time. So we'll press second trace, and then the x-intercepts are where the function value is 0, so we use the 0 feature to find the x-intercepts. So we select option 2, and let's find this x-intercept first. It's asking for the left bound. Notice in this case, if we're left of the x-intercept, we would be above the x-intercept where we are now. If we want, we can get closer, maybe somewhere in here. Press enter. The right bound would be, in this case, below the x-intercept, maybe somewhere in here. Enter. And again, when it says guess, we can just press enter again. It says round to 2 decimal places. So the x-coordinate would be approximately 0.54. So we'll say the first x-intercept or horizontal intercept is the point 0.54, 0. And now we'll find the second x-intercept. We'll repeat the process. We'll press second trace option 2 for 0. The left bound of this x-intercept would be below it, somewhere over here. Let's move the cursor over there. I went a little bit too far. Let me come back. Now the cursor is to the left of this x-intercept, so we'll press enter. To the right in this case should be above this x-intercept. Maybe somewhere in here. Enter. And then enter one more time. And again, notice how the calculator is not perfect. We need to recognize this value here as 1 times 10 raised to the power of negative 12, which is very close to 0, which is what the calculator means. So the second x-intercept would have an x-coordinate of approximately 6.46. So our second x-intercept would be 6.46, 0. Before we go, let's take a look at this graph again. Here's a graph of our quadratic function. Here's the vertex that we found.
Okay, so you guys saw how he was able to find the different parts of the graph. And so we're going to do that on our calculator now. So going back to your note guide, we are going to use the steps that he gave us as a guide. So we're going to go and calculate the vertex and the x-intercepts of the graph. So again, the first thing you need to do is you need to go to your y=, menu to enter the equation that's listed. So make sure that everything else is cleared out. Now that means if there's any other functions in there that you don't want to see on the graph, they should not be bold. And you need to check the words at the top of the y= window, the plot 1, plot 2, plot 3, and also make sure that they are not bold. Okay? And so then we're going to type this into our calculator, taking care that we put a negative and not a minus sign in front of the x squared. So negative x squared plus 6x plus 3. And again, like he said, if we want to see it in a standard window in case our window was messed up from something else, we're going to go to zoom and we're going to choose choice 6, which is to zoom standard. Okay? And again, the zoom button is up in the middle right by the graph. So zoom choice 6, you should see a graph of your parabola. Okay? It should face downward, and you can see that in your window you don't see the vertex. Okay? So again, you need to adjust your window just like he did. So again, you need to go to window. Okay? When you press window, you see x minimum, x maximum. Those were both fine. The y minimum was fine. It was the y maximum that needs to be scaled up so that we can actually see the vertex of the graph. So why don't you guys go ahead in this case and make your y maximum equal to 15. So just scroll down to y max and change that value to 15 and press graph. And you should see a good picture of the parabola. So now the vertex. Okay? He talked about getting that by going to second, trace, which is really giving you the calculate option. Okay? So when you do that, if you're looking for a vertex, you're always looking for a maximum or minimum. Since our graph is going downward, our vertex is going to be a maximum point, so we're going to choose choice 4, which is maximum. When you choose that choice, it's going to put the cursor on your graph and ask you for a left bound and a right bound. If you scroll left or right using the arrows, try to go ahead and put your cursor as close to the maximum as you think. And when it's saying left bound, press the left arrow a few times so that your cursor ends up to the left of the maximum and press enter. Then it will ask you for right bound. Scroll back up to the top and scroll a couple places to the right so that you know that you are to the right of where you think the maximum is and press enter. Then it says guess and press enter again. So here you have to find the bounds, the left bound and the right bound, and press enter. Okay? So if you did it correctly, you should see a vertex of 3, 12. Okay? Your calculator might have a little error, like mine says 3.000000016, but that's basically 3. Okay? The second thing we're going to do is we're going to go through and we're going to look at the x-intercepts. Okay? So again, that was a calculation on the calculator. Now, our graph is crossing the x-axis twice. Okay? Somewhere over here and somewhere over here. Now, we have to do this calculation for x-intercepts twice if we want to calculate each one. Okay? And each time you're going to go through the same steps. So again, you're going to go second and trace, which again is really giving you that word calc above trace, so you're really doing a calculation. And remember that we talked about when we watched the PowerPoint that these are called X-intercepts, or also called zeros or roots. So you can see that you're going to choose choice 2, which is called 0. So you're calculating a 0. Let's say that the first 0 that you want to calculate is the one that's farthest to the left. Okay, so your focus is on finding this 0 over here. And you should scroll your cursor to the left. So you're about where you see that point cross the x-axis. Now it asks for the left bound. On this part of the graph, if we're looking for this x-intercept, to go to the left of the x-intercept in this case is also moving downward. So you're going to make sure that your cursor is down below that x-intercept before you press enter. Then it asks you for the right bound, so just arrow back up the graph so that you're above the x-intercept, because that would be to the right. Press enter, and then it says guess and press enter again. One of the x-intercepts that you should get then is negative 0.46, 0. And then we're going to go ahead and find the other one. So we're going to repeat this procedure focusing on this x-intercept over here on the right. So again, second trace, which will get you to the calculate menu, and choose choice 2, which is 0. Arrow over so that you're near the 0 that you want to calculate. So you want to use your right arrow to get over here in this arena. And the first thing it asks you for is a left bound. Now, if this is the point that crosses the x-axis, moving up the graph would also be moving to the left of it. So I'm going to just use my left arrow so that I put my cursor somewhere up here and press enter. And then for the right bound, I'm going to use my right arrow, which moves my cursor back down over here, press enter, and then enter again to guess. And you should get an x-intercept of 6.46, 0. So you just found the x-intercepts using the calculator. So with this information, we should be able to look at this, and it asks us first for the axis of symmetry. The axis of symmetry goes through the middle of our parabola, which means it's related to that vertex point, which we can see has an x-coordinate of 3. So the axis of symmetry is going to be that x equals 3. The minimum or maximum value. Now in our case, it's a maximum value because our parabola is concave down and the vertex is a maximum. And since it's asking for the maximum value, it's asking for the highest point that it reaches, or the highest value that the y-coordinate will become, which in this case is 12. The domain, like all the parabolas that we studied, is all real numbers because we can plug in any x value. And the range in this case, our graph travels forever downward, so we don't have to worry about that. But the highest point it reaches is that point that was up there at 12. So our whole graph, all of the y values, are lower or equal to 12. So the range is going to be that y is less than or equal to 12. So again, what we would get from here is being able to figure out this information on the calculator, but still being able to interpret that the same way we did before to figure out axis of symmetry, maximums, minimums, domain, and range. Now, how to do this without the graphing calculator when the equation is in standard form. So if I want to graph this equation by hand, and it's not written in that nice vertex form where I can pick out the A, the H, and the K. But remember that when we looked at the PowerPoint of all these different forms of the equation, this was considered the standard form of the equation. And there was a formula that we saw that went with that. And this formula specifically figured out for us the x value for the vertex as well as the value for the axis of symmetry. So in our case, our b value is negative 16. And we're looking for a, b, and c from the equation. So our b value is negative 16 and our a value is 4. So this becomes 16 divided by 8, which is 2. So x equals 2 is our axis of symmetry, which means I expect this axis of symmetry on my graph. X is equal to 2. That also means that my vertex of my graph has to be on that line, which means the x-coordinate is 2 and I need to establish the y-coordinate. So I'm going to go ahead and take that value of 2 and plug it into my equation to see what I would get as a y-coordinate. So I'm going to have that y is equal to, let's see, 2 squared is 4, and 4 times 4 is 16, minus 32 plus 10, which is going to give me negative 16 plus 10, which will be negative 6. So my vertex is the point 2, negative 6. So 1, 2, 3, 4, 5, 6. So there's my vertex of 2, negative 6. I expect this parabola to be concave up because the a value is positive 4. And I also expect it to be stretched vertically compared to the parent function because of that a value. Now, to quickly get a point on one side of the axis of symmetry, I could choose an x value. So in my case, I'm going to choose 1 because 1 is close to the axis of symmetry, which is 2. And I'm going to plug that into my equation as an x value and finish the calculation for y. So in this case, I'm going to get 4 minus 16 plus 10, which gives me negative 2. So I plugged in 1 and I got out negative 2. So the point 1, negative 2 would be on my parabola. And the mirror image of that point would be there as well. And that kind of shows you how narrow or vertically stretched our parabola actually is. So just as before with vertex form, you were able to get a graph of the parabola with all the important parts. You should be able to do that with this standard form also, just with a different starting point. Okay, and we picked out the vertex as well as the axis of symmetry. So the next problem we see here in our note-taking guide doesn't have a graph. We're not supposed to graph. It's more of a word-based problem. So a model for the performance of a stock is that P is equal to negative 3D squared plus 50D. D represents the days of trading, and P is the price per share. What is the maximum price per share of the stock? So before I start going crazy about all the words in this problem, the equation they gave you to model the problem you should see is a quadratic, which means it is shaped like a parabola, which can have a maximum or a minimum point. Given that the equation of this parabola starts with a negative 3, that means I picture this parabola being a parabola that goes downward, okay, because that a value is negative. So when they ask me, and remember that my x-axis in this case versus my y-axis, and this is kind of a rough sketch because I have no idea where this parabola is. I didn't do any of that. But P is kind of the y value that I'm calculating, and D is kind of taking the place of my x. And my goal is to find the maximum price per share of the stock. So I really am looking for a P value, and that maximum price is going to be how high up that parabola goes. So then the question is, how high up does it go? Well, I can't figure that out without knowing which D value is causing that maximum point. So what I would want to do is find out what D value is centered in my parabola, or what D value is with the axis of symmetry. So again, given that it's in standard form, I can use this formula to calculate my axis of symmetry and the x value, or in this case, the D value of my vertex. So according to their equation, A would be negative 3, and B would be 50, and C would be 0. So here, I have negative 50 divided by 2 times negative 3, which is going to give me 50 divided by 6, which turns out to be 8 1/3, or 8.33 continuously. Now, that's an x value, or in this problem, a D value. So that's telling me the vertex is occurring at this point. But the question wasn't the number of days of trading where it reached the maximum. It was what is the actual maximum price, so the P value. So again, this vertex point up here has this D, or this x value, and then associated with it, it would have a P value telling me the maximum price. So what I'm going to do is I'm going to find that P value. So I'm going to take the equation that calculates P, and plug in the D value that I know is associated with that maximum price, which is 8.33. Okay. And then I'm just going to continue and finish this calculation. And sorry, I forgot to square it on there. So you would take 8.33, and depending on if you round it or not, that would affect your value a little bit, but you're going to square it, multiply it by -3, and add 50 times 8.33, giving you 208.33. And so then that was the maximum price that we were looking for. All right, so your job is to complete homework number 4 from your assignment sheet. With the information we gave you today and the information you have previously, it shouldn't be too bad. We have our class set of books. They are on the side desk, and so you guys can use some of those to share. There might not be enough, so what you can do is you can take a picture of the page that the homework is on, and then you can use that to do the problem. So if someone gets a book, just walk over, take a picture of the page, and keep that out. But let the substitute please know that you are using your phone to get the problems from the book. And if they see you doing anything else on your phone, they have the right to take your phone and turn it into supervision. So please remember that. And then I will answer homework questions you guys have on homework 4 and some lingering questions from homework number 3 tomorrow. And then don't forget to bring that handout tomorrow because we're going to do the cool ball toss activity, see if we can collect some data that works with quadratics. So I will see you guys tomorrow.